Hello students, as of now, I have covered the introduction to pattern recognition, the pattern recognition procedures, pattern recognition components, and its design cycle. So today I'm going to cover a very important topic on dimensionality reduction. As we all know that in machine learning, dimension simply refers the number of features, that is the input variables in any data set. And dimension reduction is the process of reducing the number of variables and selecting only the principal variables, which is important, which is useful for the classification purpose. And this dimensionality reduction can be divided into the two. One is feature selection and one is feature extraction. Now, before starting the feature selection and feature extraction, we should know what is the purpose of dimensionality reduction, what the problem occurs while selecting the features. So there are two problems arises. The first is the curse of dimensionality. The curse of dimensionality, that is when the number of features are very large. So it would be very ineffective to train the model. So this is called the curse of dimensionality. That means from our data set, we cannot take all the features to design my classifier, because at that time I need to make difficulty while training all those classifiers. The second problem is peaking phenomena, which says that if the number of features we are taking less, or we are taking less number of features, then obviously we are degrading the classifier's performance. That means my classifier won't be able to give an accurate result. And unfortunately, the probability of occurrence of error would be high. So, according to this graph, we can easily see as the number of features large, the classifier performance get degrade, the classifier's performance get low. So this means that we have to choose the features very wisely whenever we need to design a classifier. So as we have said, there are two important ways of dimensionality reduction. So one approach is feature selection and one approach is feature extraction. Feature selection basically filtering, or you can say feature selection is the process of filtering irrelevant and redundant features from the data set. So suppose if I do have n number of data set and I have chosen m number of data from this data set, then my m would always be the subset of n. That is feature selection जो है, that keeps the subset of whole data set. So you can have this data set and we do have a feature selection which is the subset of this one. The second approach, which is feature extraction, which actually creates the new features that captures the most of the useful information. So basically, we do have a set. We do have a data set. We extract the features from it. From these features, we can create the new ones. We can create the most useful ones through which we can discriminate the patterns very easily. In both the cases, the goal is the low dimensional representation of the data. One important thing that feature extraction जो है, that can be either supervised or unsupervised. And you do have an idea about what I mean about supervised and unsupervised. So feature extraction is, so if feature extraction for supervised, we are using linear discriminant analysis method, and for unsupervised, we are using principal component analysis method. So it would be very clear कि when we use these approaches. So dimensionality reduction में we do have various methods. The most popular, or which is covered in our course, we'll talk about the principal component analysis and the linear discriminant analysis. Now, in the last section, the advantages of dimension reduction is that is we can easily, first thing, we can easily avoid the curse of dimensionality. We can make our classifier faster, or we can have less consumption of my memory or less consumption of my time, and we can easily simplify the representation. That is, we can easily visualize the data set. And the disadvantages exist. There could be a possibility of loss of information. And basically, this happens only when we do not have very much experience on our data set. Then that could be happen. We select some wrong features so that we are actually degrading our classifier, and the probability of having errors would be high in that case. So this is the disadvantage of dimension reduction. So I'm ending over here. I hope you get an idea about the dimensionality reduction. Later on, we will cover these two methods. The one is principal component analysis, and the second one is linear discriminant analysis. Thank you, students. Hope you guys are learning in this crucial time. Thank you. Keep watching and keep listening.